What happens to your brain when you go to space? Science says nothing good. A new study conducted by MIT compared MRI scans of 26 astronauts pre- and post-spaceflight and showed that being in space physically moves the brain inside your skull. Yikes! Extended spaceflight causes the brain to shift upwards and backwards and to tilt, with a shift up to 2.52 millimeters. That's a lot! You can see 2.5 millimeters with your bare naked eye. And the longer you stay in space, the bigger the shift. But why does it happen? You saw how liquids tend to float around in microgravity, right? Well, the absence of gravity changes the way fluids behave. All the fluids. Also the fluids inside of your body. It triggers what is called a cephalic fluid shift, where bodily fluids redistribute toward the head, for example. The astronauts on board of the ISS do look puffier once you start noticing. Also, the change of pressure causes the redistribution of cerebrospinal fluid and the expansion of brain tissue upwards, what is called vertex crowding. Here is where we care. We like our brains not squashed around. Just an example of possible ugly consequences. It messes with your eyes. As the brain moves and fluids build up, it can increase pressure behind the eyes and on the optic nerve. This is linked to what is called spaceflight-associated neuroocular syndrome, or SANS, which can actually flatten your eyeballs and cause permanent vision changes. Now, when the astronaut returns to Earth, you'd expect gravity to just pull the brain back down immediately and fix everything, right? You wish! Even 6 months after landing, the brain hasn't fully moved back. So there are long-term side effects of being in space. And they correlate with how long you stayed in space. So now the question is, what would happen in longer space flights? For example, if we went to Mars?